Lesson on hub controllers will explain some hub controller use cases and describe the hub controller configuration process. At the end of this lesson, you will be able to define hub controllers, explain hub controller use cases, and describe hub controller configuration. We'll begin by discussing what a hub controller is. The Versa hub controller is also called a hub and controller node, or HCN. It is a VPN concentrator and route reflector that provides secure connectivity from the branches to the head-end nodes. As a Versa controller, it provides the control plane backbone for exchanging real-time reachability, route, topology, performance, and SLA information between branch offices. The first use case for deploying a controller as a hub controller is for scalability. In this example, branches A, B, C, and D are connected to the controller for the control plane functions. This is a typical topology and may work in the initial deployment phase. However, in the long run, you may want to scale the number of devices or controllers. One way of doing this is by adding new controllers to the same design. Some organizations want to place controllers closer to the branches. In this example, we can replace branch D with hub D, which will also have the same functionality as a controller. This means that some of the branches can be connected to this hub, and therefore need not establish connection to the main controller. This allows better scalability in the network. Note that the main controller has a recommended limit of 2,500 IPsec connections. The number of tenants also dictates the number of IPsec tunnels. These two factors affect how you design your controllers in the head end. For example, if you have 2 tenants in each branch, then there will be 2 connections between each device and the controller. This means the branch limit becomes 1,250 devices because there are 2 tenants on each device, which requires 2 IPsec tunnels from each physical device. By deploying the hub as a hub controller, the hub controller can support 2,500 IPsec tunnels, thereby increasing scalability of the whole design by distributing the control plane IPsec tunnels across multiple devices. The next use case is discontinuous networks. In a continuous network, you have Internet and MPLS connectivity to all devices. In some cases, you may have connections that are discontinuous from the rest of the domain. In this example, the MPLS2 domain is not connected to the regular MPLS, nor is it connected to the Internet. The problem in this scenario is that for branch D to connect to the controller, it has to either be connected to the regular MPLS or the Internet. Right now, branch D is only connected to MPLS2. There are 2 ways to solve this and establish a branch D connection with the controller. The first method is to implement a controller behind the branch topology, in which branch D will establish a connection to the IP address of branch C in order to connect to the controller, which is located in the head end. This is the traditional method of establishing connection in a discontinuous network. The second method, which is relatively new, is to change one of the branches to be a hub controller. Note that this branch has to be the one that is connected to multiple transport domains, and in this example is branch C. Hub C will act as a hub as well as a controller. If branch D or E needs to communicate with either branch A or branch B, the connection will go through the MPLS2 to the hub C, and from there to the destination, which can either be branch A or branch B. This same solution can be used for scenarios in which the branches are not connected to the regular MPLS connection, or for branches that are not connected to the Internet. There are various requirements for the hub controller or HCN deployment, which are: the HCN can be deployed through ZTP processes like normal hubs and not like controllers. A template workflow can provide the option to create a post-staging template for the HCN. A template workflow for the HCN should allow the addition or deletion of sub-organizations. Spoke groups should show the HCNs or hub list of the selected organization. The add device workflow should result in programming the PSK or PKI information on the HCNs, similar to what happens with regular controllers. Spoke branches should be able to select local regional hubs as staging controllers for the ZTP process. Let's look at how to deploy a hub controller. First, create a template for the new hub controller. To do this, navigate to Workflows, Templates, and then click on the Create Template icon. In the Create Template window, specify a name for the controller and select the device type as Hub Controller. Then specify if the controller should be a staging controller. Specify the organization, select the controller, and click Continue. In the Interfaces tab, select the port configuration, which in this example is WAN. Then select the network name and IPv4 configuration for each of the 3 WAN ports. Similarly, select the port for the LAN configuration and specify the network name and organization to which it belongs. Next, navigate to the Management Servers tab and click Create. Next, we need to add a device. To do this, navigate to Workflows, Devices, and then click on the Add Device icon. In the Add Device window, specify a name and serial number for the device. Select an organization and then click on Plus Device Group. In the Create Device Group window, specify a name for the device group, select the Post Staging template, and click OK. In the Add Device window, verify that the device group information is populated and click Continue. In the Location Information tab, specify the location information and click Continue. In the Bind Data tab, click on the serial number of the controller. In the pop-up window, notice that in addition to the LAN networks, MPLS networks, and DR gateways, you can input multiple staging prefixes. Specify the values and click OK. Now the device is ready for onboarding or deployment. Click Deploy. To validate if the staging or deployment is successful, navigate to the console of the device and run the onboarding command. You have reached the end of this lesson. In this lesson, you learned that the hub controller is a VPN concentrator and route reflector that provides secure connectivity from the branches to head-end nodes. The hub controller helps scale a network with ease and addresses the challenges with a discontinuous network. And to implement a hub controller node, you need to first create a template for the new hub controller and then add a device. Once the deployment is complete, you can navigate to the console of the device, run the onboarding command, and validate the staging completion.